Okay. I have anything to give back to y'all. This is not y'all. This is not y'all. Oh, there's y'all. Mia is a person in this class. Okay. Let's see. Oh, gotta grab my books. Back. What are you thinking, bro? Why'd you put these dishes in my thing? You did. You only did. It's all your fault. Do you have any questions on the quiz I gave back? Start with that. Okay. So we did 3, 5, and 3, 6. Does that sound right? Okay. Great. Grand, glorious. 3, 6 was the one I warned you about, wasn't it? Yeah. Oops. All right, so 3, 5 it is. What numbers did we do on 3, 5? 8 through 20. Number 8. 8 through 28. Number 8. R is parallel to S because of the converse of the corresponding angles postulate. And number 10. R is parallel to S because of the alternate interior angles converse. And 12. U is parallel to V because the consecutive interior angles converse. I'll remind you that when I'm saying consecutive, if you put same side, that's totally fine. Number 14, no lines can be proven parallel. Number 16 is 39 because the alternate exterior angles converse. 18 is 63 because the alternate interior angles converse. Number 20 is 27 because of the vertical angle theorem and consecutive interior angles converse. There's probably another way to get there, like using the supplement theorem or something like that. If we need to look at that one for that reason, be totally fine. 22 is yes. When two pieces are put together, they form a 90-degree angle. Two lines that are perpendicular to the same line are parallel. Number 24 is since the corners are right angles, each pair of opposite sides is perpendicular to the same line. Therefore, each pair of opposite sides is parallel. 26 is a proof, and 28 is a proof. We can take a look at those as we need here in a minute. What questions do you have that are not the proofs? Okay. Can we do 20? Sure. Let's see. Where is the black marker? Is it right here, maybe? No? Where did they put it? They ate it. Yeah, I think I've got a few more. Number 20. Find x so that those are parallel. Identify the postulator theorem used. Got a couple lines like this. We got this one labeled as 2x plus 45 degrees. And this one is labeled as 3x degrees. Okay, so what are those? What? They're angles, is that what you said? They are angles, that's true. Are they consecutive? Are they corresponding? Are they alternate something? Are they consecutive or same side something? Or are they none of those things? This one's not exterior. They're nothing. So you got to use more than one thing to get there, right? So we need to figure out how they're related. So this one and this one, how are they related? They're vertical angles. How are vertical angles related? They're congruent. That's true. So this is congruent to this. Now this one, how are they related? This one and the other one that we know. This guy right here and this guy right there. How are they related? They're same side interior, right? So how are they related? Yeah, are they congruent or are they supplementary, right? Supplementary, that's true. So what would the equation look like if they're supplementary? 180. So 3x plus 2x plus 45 equals 180. And then we can solve that. We're going to write down the theorems so we don't forget. We use vertical angles, right? And same side interior. Right? So to solve that guy, what would we do? Where are they? So what's 3x plus 2x? 5x. Now what? So what's 180 minus 45? What? It is 135. That's true. Now what? Divide by 5. So x equals what? What? $20 what? Okay. Anything else from that lesson? Okay. So before we go back and grab that proof, let's take a look at the other lesson. Assuming we need to look at the proof. Either one of them. All right. What did we do on 3-6? I cannot understand you. 14 through 28. 14. Path B. Shortest possible distance would be the perpendicular distance from one side of the courtyard to the other side. Since path B is the closest to 90, it is the shortest of the three paths shown. Number 16 is the square root of 74 units. Number 18 is 3 units. Number 20 is 3 units. 22 is 4 units. 24 is 1.5 times the square root of 10 units. 26 is 19 units. 28 is 2 times the square root of 10 units. We went through what number? 28. We didn't do any of those other ones? We didn't do 32? That's crazy. Okay. Oh, but we did do 16 through 20. Yeah. Great. What questions do we have on those? 26. Find the distance between each pair of parallel lines with the given equations. Now where's my eraser? They took everything out of here. Oh, there they are. They just fell over. That's fine. Okay. What number did you say? 26. All right. Distance between two parallel lines. That one's the easy one, but that's all right. We got this. It's not easy if you don't see what's happening. Between y equals 15 and y equals -4. What do those lines look like when we graph those lines? Yeah, they're horizontal lines at y equals 15 and y equals -4. So how can we find the distance between those two? Just subtract, right? Were you saying count? Is that what you were saying? What were you saying? Yeah, you could. So 15 minus -4 is how many? It is 19, yes. Because you ka-chink, and it's 19. What other ones from that lesson do we have? What? 24? Oh, I was about to say that's another easy one, but it's not. All right, number 24. We're supposed to find the distance between y equals 1/3 x minus 3 and y equals 1/3 x plus 2. All right, we're supposed to find the distance between those two parallel lines. So what should we do? Between what? We are going to use the distance formula, but to use the distance formula, we need 2 points. Okay, we can graph. Is that what you just said? Okay, sure, we can graph it. How would we graph this one? -3, right? And then up 1 over 3. And you get your ruler out and you draw the line, right? Now what? What points? What? No. It would be -2 and 3. That is a point, yes. But you can find did you? This thing has infinite points, right? So does this one. If we go up to 2, right? And then we go up 1 over 3 and we do it again, right? We got another line up here. This has infinitely many points on it. There's a point right here, and 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 a point, etc. Right? The same for this one. If I find the distance between this point and this point, that's going to be totally different than the distance between this point and this point. Totally different than this point and this point. So we need particular points, right? Which is what PassMe did on the internet, right? I don't know what that banging around is. Because I did do an example of this in the video, right? Am I right, or am I like straight tripping? Okay, good, good. So, what do we do? Change the slope to, oh yeah. You're in the right vein. Change the slope to what? -3. Yeah, so we're gonna find a perpendicular line, right? So we're gonna pick, you're gonna do either one. So we're going to find a line that is perpendicular, right? That goes through maybe the intercept, right? Is that what we did? Yes. So we're going to find one that is perpendicular. This is the last unit. So perpendicular lines have opposite reciprocal slopes. So you're right. You're going to find, for the slope of our new line, it is going to be the opposite reciprocal of that, -3. Now what? Do what? We don't have a line to graph yet. We don't have an equation of a new line yet, right? We got to find the equation of, we're looking ultimately for this line, right? We're looking for a line that goes through this intercept, this point right here. What is this point right here? This one. What? It's a y-intercept, so what is the point? It's this line right here. What numbers? No, not this one. And that's -3. And this is the slope, not the y-intercept. Where's the y-intercept on this line? 2. So it's 0, 2, right? So we're trying to find the equation of this line that has the slope of -3 and goes through the point 0, 2, right? So what can we do now? Substitute the -3 in somewhere. That's true. And where? The slope what? Of what? What equation are we using here? What is the equation for a line that we know? The slope formula is m equals y2 minus y1 over x2 minus x1, which is not going to help us probably, right?
Point slope.
We could use point slope. Let's go ahead and get a collection of formulas while we're remembering things. If you are not remembering this, I am not kidding when I say what you need to do is make a flashcards and start spending time memorizing it. Get your mommy to help you, or your daddy, or your brother, or your pet goldfish. I don't care. This needs to be in there. I said about lines, I said that last year, right? I suggested strongly that you go to Khan Academy and make sure you know how to graph a line. If you don't, by the end of the thing, because of whatever reason, you gotta get this in your brain. This has got to be there. If it's not, it needs to be there. Point slope. What is point slope? Do you remember it?
Y minus y1.
Y minus.
Slope times x minus x1.
Yeah. This is the slope formula. This one. What is the slope formula for? Finding the slope. That's true. This is point slope. What is point slope for? If you're given a point and the slope, which we are, you can plug them in here and you have an equation that you can graph from, right? There's one more, the one that we use even more often than point slope. To be clear, I would rather you like participate and say something out loud that's wrong, because then we can fix it. So don't be afraid to say something just because you think it's wrong. It is the slope-intercept form. Well, that's fine. That's fine. I'm not just talking to you. You're one of the ones trying to say things today. Slope-intercept. What is slope-intercept form? Yeah, m plus b. That's true. Great. So we plug that into one of these. We're given a point, we're given a slope, so let's use point slope. Why not? It's a good idea. What are we going to plug in for y1? Yeah, but what is the point we're using? It is 2. So y minus 2 equals negative 3 times x. And what are we going to put in for x1? 0. Minus 0. Now what are we going to do? Distribute, sure. So what is going to happen to this minus 0 though? Does that do anything when we subtract 0? No, he's going to just cancel. He's just going to disappear, right? All right. Now what are we doing? Remember our ultimate goal, and I didn't like rewatch the video, so I don't know what Pat May told you. So I may be giving you new information, I may be giving you old information, who knows? But you gotta, in these problems, nothing is really that difficult. There's just a lot, and it's very helpful if you can keep in mind what you're trying to do. And what we're trying to do is we're trying to find the equation of this line. Because then, if we know the equation of this line, which we just did, then we can use a system to find this point. And then we got 2 points that we can use the distance formula, right? So we're trying to find this point right here, right? The line where they cross. So to find the line where they cross, what are we going to do? Divide what? What are you thinking? Or are you just saying words? Okay. What are we doing then? Yeah, we could. We're essentially taking it from point slope and putting it into slope intercept is what doing that would do. You don't have to do that on this problem, but it may make it easier to do something in a minute. Y equals negative 3x plus 2. So that is, to be clear, that is the equation of this orange line right there. That's that equation. So we know that equation. The equation of this one is y equals 1/3 x plus 2. And the equation of this one is y equals 1/3 x minus 3. And we just discovered that the equation of this one is y equals negative 3x plus 2. So what is our next goal? Even if I'm asking that question and specifically, and I know I just talked it all out, but the more you think about goals, the easier it's going to be like, okay, I can actually do this problem, right? So, excuse me, what is our goal right now? What are we trying to find? The what? So yeah, okay, so that's our ultimate goal, but the distance between 2 points, right? Do we have 2 points yet? No, we only have 1 point. So what are we trying to find now? The other point, right? We're trying to find this point right here. We have a method, we have a tool for finding where 2 lines cross, right? We can solve this little system. So what 2 equations are we using? Which 2 equations are going to make up the system? Which ones cross? Yeah, this one and the one we just found, right? So we're trying to find where they cross. So now what do we do?
Substitute for 1.
Yeah, substitute it in there, right? So negative 3x plus 2 equals 1/3 x minus 3. Now what do we do? Yeah, solve, more specifically though. Subtract what? Sure, that's fine. We could start by subtracting 2. So then we've got negative 3x equals 1/3 x minus 5. Then what? You wouldn't divide 3. Actually, you could multiply 3, get rid of the fraction if you multiplied 3 on everything. That would be a way to do it. Yeah, you're going to try to get those like terms together. How do we move it from one side of the equation to the other side of the equation? Subtract's fine. Subtract what? The 1/3 x? No, if you were moving that one, you would add it, right? Okay, so what's negative 3 minus 1/3? No, it's definitely not 1. Your calculator will do that, even if your brain is sluggish, right? Let's do it as an improper fraction because it's going to be easier to deal with in a minute. I think you didn't do them both negative. Negative 3 minus 1/3. Negative 10/3, yeah. I forgot the x. Now what? Yeah, how do you divide fractions? Multiply by the reciprocal. That's true. That's true. Gavin found his voice. Good job, Gavin. Over 10. So x equals what? It's positive, right? Because the negative 5 times negative 3/10. 3/2. Great. Now what? Substitute again. That's true. Into which one? Whatever one. I think doing it in this one is a good idea. This one, because then the 3 and the 1/3 are going to kind of do some canceling magic, right? Okay. So y equals 1/3 times 3/2 minus 3. What's a third times 3/2? Well, look, before you even punch it, stop and think for a second. The 3 and the 3 reduce to 1 and 1, right? 1/2. And then what's 1/2 minus 3? It's negative 2.5, which is the same as 5/2, right? Now what? Distance formula. What are the 2 points we're going to use? 0, 2. And the 1 down there. 3/2, negative 5/2. What is the distance formula? Point proven. Great. Yeah, 'cause I don't hardly ever hear you. You're like barely you're talking out loud. Anyway, as we were saying, perpendicular transversal theorem. Great. Yippity skippity. We don't have time to like fully do 26, but let's look at it. Talk it through. So if you're not on page 212, get on page 212. So you've got what appears to be a parallelogram. We could probably prove that it's a parallelogram if we had enough information. But we don't know. So we're told that WY is parallel to YZ, so that's those slantways ones, right? So those are parallel. Angle 2 and angle 3 are congruent. They're supposed to prove that the top and bottom ones are parallel, right? So how would we do it? This one's a little bit trickier, right? Because we don't have anything on a single transversal, right? Because how are 2 and 3 related? Are they anything? No, they're on opposite sides, right? So we'd have to do like 2 and 4. How are 2 and 4 related? They are. So how are they related? Supplementary. So we'd say they're supplementary. Their sum equals 180. And then since 2 and 3 are congruent, what can we do with the 3 in place of the 2? What's taking that 3 and replacing it called? Substitution. So we can replace that. We'd get measure angle 3 plus measure angle 4 equals 180. Which tells us, since they add up to 180, what are they? Supplementary. True enough. They are, so 3 and 4 are supplementary. If they are supplementary, if they're supplementary, then what's true about the ones that they are transversing across? They're not congruent. They're same side, right? They're supplementary. So the converse of interior angle theorem. Bob's your uncle, done. Okay, kids, you have a test on Thursday. I would recommend studying. If you want answers to the practice test, ask for them. One and only one of you has consistently done so in this class. That is one of the best ways to study for the test, I'm telling you right now. Because then you have the answers, you can see if you're on the right track, or if you need to clear something up, or if you need to send me a question, or whatever else.